Alright, so what we're going to end up doing is talking about limiting a domain and graphing, well, equations. So let's go over what slope-intercept form of a line is, because we're going to be graphing linear functions, and most of them are going to be in slope-intercept, which if you remember from Algebra 1, that could be a couple years ago for some of you guys, is y is m, our slope, x plus b, our input, our output, our slope, our y-intercept. I'll point to them again. X is the input, y is output, m slope, b is y-intercept, which is just what I wrote here. All right. Remember, b being the y-intercept, that's where it touches this y-axis. Our slope is our change in y over change in x. If it's written as a fraction, let's get into it. All right, so we're going to come down here. I'm going to write over it y equals mx plus b. So let's see, b is 1, right? B is 1. It's in the right format, so I'm going to put a dot at 1. And my slope is whatever number's in front of x, which is 1. So my slope is up 1 over 1. It's 1 as well. Up 1 over 1, up 1 over 1, and I'm getting a line that I messed up a little bit, but looks about like that forever. Let's do this one. I'm going to write mx plus b. My b is -3. Put a dot right there. My slope is 1/2. That is rise over run, y over x. So from here I go up 1 and right 2. They're both positive. So from here I go up 1, right 2, and I put my next dot, up 1, right 2. I hope you guys remember this. And I draw my line. Alright. Less work here. I'm going to say my y-intercept's -5. Just going to point to it. Is that -5? No, that's a +5. My slope is, the negative doesn't matter if it's top or bottom, so I could say -3 over 2. That's probably the, or if I wanted to, I could say 3 over -2. Neither one matters, but this one is easier to graph because from here it's easier to go down 3, 1, 2, 3, and right 2, right 2, 1, 2, 3, and right 2, and I can connect it, and there we are. All right. So what we're going to do is we're going to restrict the domain and do this. We're going to tell it, hey, we have x values we're not allowed to do. Alright, so unless otherwise stated, functions assume to have a domain of all real numbers. Alright, many functions such as linear, quadratic, exponential functions are defined for all real numbers, so their domain is all real numbers, which can be written a couple different ways. There's this kind of funky looking real numbers like that, right, as a real number set. As an inequality, I could say negative infinity less than x, which is less than infinity. That's all real numbers. Set notation, same thing, right? I could say x bar negative infinity less than x, which is less than infinity. And for interval notation, I can just go negative infinity with my parentheses, comma infinity. All right. In some world situations modeled by mathematical functions, all real numbers doesn't make sense. Like if we were talking about years, we can't go negative infinity. The planets have been around for a finite number of time. The universe has been around for a finite number of time. In these cases, we need to restrict the domain. If the rule of a function and its restricted domain are given, you can draw the graph of the function and then identify the range. So here it is, right? We've got this equation we could draw. I could go to 2, I could go up 3 over 4, right? Up 3 over 4. All right, I could go down 3 over 4 to get the other side, down 3 over 4. Let's talk about what I just did with that, right? I said, hey, my y-intercept is 2. My slope is either up 3 over 4 or down 3 over 4. And honestly, in this situation, what I've done is I have really got this because I've already limited my domain. It goes to -4 and it goes to +4. This isn't always the best way to do it, but it's one way, right? I can just plot the line and then cut it off. All right, just because there's more examples over here, I'm going to show you another way to do it. All right, so sometimes they will give you, right? They'll give you something. This says, hey, I have a limited domain only to the fact that it's greater than -3. So I'm going to plug in -3 and I'm going to get 1 point, right? I'm going to go f of my new input. I'm going to plug in negative 3 there, and I'm going to plug in negative 3 there. Look, I got two negatives here, right? So what I did is I put that negative, and then for x, I plugged in negative 3. I would just replace that, which of course gives me a positive 3 minus 2. So when I plug in negative 3, I get 3 minus 2, I get 1. So I'm going to come over here, I'm going to go negative 3, 1, and I'm going to see if that's an equal sign. It isn't, so I'm going to put an open circle. And I'm allowed to get bigger than this. It says I'm allowed to get greater. I'm allowed to go to the right. So it's an easy way to do this. I can just use my slope. So if I come up here, my slope is negative 1. It says down 1, right 1. So from here, I can go down 1, right 1. And it's going to continue that pattern forever. Although, apparently I don't draw very straight lines. And it's going to go like that forever. And that would be that graph. It says reflect. I'd like you to reflect. Alright, but let's go C and D first. Let's get C and D. Alright, I'm going to show you a new way to do this. This is restricted between two numbers. So instead of graphing it and stopping at negative 6 and positive 2 on my domain, from here, right, to here, I'm going to graph. I'm going to plug these in. So I'm going to say a function of negative 6. And then I go negative 1/2 times negative 6 plus 2. We can do this in our head, right? Negative 1/2 and negative 6. Two negatives make positive 3 plus 2. So when I plug in negative 6, positive 3 plus 2 is 5. I get the point negative 6, 5. Right? And I'm going to plug in 2 because that's the other end. So I'm going to go a function of 2 equals negative 1/2 times positive 2. Plus 2, negative 1 plus 2, so a function of 2, that's negative 1 plus 2 is 1, and so when I plug in 2, out comes 1. Now we're just going to make sure we use everything correct. So I touch the boundary at negative 6, so negative 6, 5, which is right here, I'm going to fill in. There's no equal sign here, so I don't touch the boundary on the right side, so 2, 1, I don't fill. Oh, open circle. I did that wrong. Should have been open circle. I'm not going to erase it. I'm just going to put that open circle around it, and there's a line in between. Alright, another easy one. So I'm going to go ahead and look at, we got a little bit more to go, but I'm going to stop this after this one. You guys are almost done with this page, and then a little bit more. Alright, so this one doesn't have a boundary on the bottom, but it has a boundary on the top. So let's get the boundary to the right, right? The domain goes to negative infinity and never goes past 3. So I'm going to go a function of 3 equals 2/3 times 3 minus 1. 2/3 times 3 is 2, minus 1 is 1. Alright, so when I plug in 3, I get 1. So there it is, 3, 1. And let's do it. Let's go to 3, 1. It's right here. And let's just look at our slope. Our slope is either up to right 3, or this is the same thing. And this is going to help me get my next point, because up to right 3 brings me out here. If I use two negatives, down 2 and left 3, 1, 2, 3. Well, you know what else I could have done? I could have just used that y-intercept at negative 1, huh? Either one of those would have worked. Make sure we're doing it right. I am touching the 3, so I'm going to use a solid circle, and then I'm going to down 2, what's that? Down 2 over 3. Let's try that again. Down 2 right to there. And it's going to look something like that forever. Alright. I want you to make sure you have this reflection done right here. Might be the only thing I check tomorrow, and that's the first video.